today we're learning about mutually exclusive events. Mutually exclusive events basically means that two things cannot be the same at once. And then keep in mind the probability either of two mutually exclusive events A and B will occur if it's the sum of the individual probabilities. And the formulas for that is probability of A or B equals to the probability of A plus the probability of B. And then, so if you see like in a Venn diagram fashion, we have box, and then you have the number of things in A, and the number of things in B. And then number of things in A and B is 0 because there's no overlap because these two are mutually exclusive. And then, so, example 1. Get closer. Example 1. So if Jennifer rolls 2 4-sided dice, determine the probability that she will roll a sum. Determine the probability that she will roll a sum that is either 6 or an odd number. Okay? So this is the question, right? And then the first step we have to do is consider whether these events are mutually exclusive or not. And then they are mutually exclusive because both events cannot occur together since 6 is on the odd. Because you have to find a 6 or an odd number. But 6 is even, and even and odd numbers are not the same. So it's not. So they are mutually exclusive. And just film the board.
Yeah.
So step 2. You have to make a table of possible sums. So make a table of possible sums. Possible sums when a pair of 4 dice, 4-sided dice are rolled. So we have 1, 2, 3, 4. 1, 2, 3, 4. Add them together. 1 and 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 2 plus 2 is 4, 5, 6, 5, 6, 7, 6, 7. 4 plus 4 is 8. And then you have to find, the question is, she will roll, the probability she will roll a sum of this, either 6 or an odd number. So what is an odd number? Odd number is 3, 3, 5, 5, 5, 7, 7. And then, or a 6. and then you find it here, and then step 3, determine the individual probabilities in the table. So in this case, I use A to represent 6, and B to represent the odd numbers. Okay. Then, using the formula, which we know as probability A plus probability B, and what is the probability of A? There's 4-sided dice, two four-sided dice, so 4 times 4 is 16. And then in the 16 you have 3 6s. So for A, the probability of A is 3/16. And then we know that there's 8 odd numbers. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 8 odd numbers in the 16. So for the probability of B, you have 8/16. And step number 4 is basically just calculate using the formula. Calculate the probability using the formula. So we know the formula is probability of A or B equals the probability A plus the probability of B. So, and then we know that the probability A is 3/16, the probability of B is 8/16. So what we do is, we first write down the basis question. Raise the question with more space to write. So, first then what we do is, we write down the formula. Probability of A or B equals the probability of A plus the probability of B. Remember every single time before you do a question, write a formula out so you know what is defined and what. Make sure you have what you're trying to find and the formula. So when you do the question, just plug it in and you get the answer. And then, second, after this, the probability of A or B equals the probability A plus B. So we know what is the probability A. Probability A is here, 3/16, right? So we substitute 3/16 for probability A. So 3/16. What's the probability of B? We know the probability is 8/16. So we use 8/16 to substitute for the probability of B. Right? And then what's 3/16 plus 8/16? Since the common denominator is the same at the bottom, since we have the same common denominator, all we have to do is add the top numbers. And what's 3 plus 8? 3 plus 8 is 11. So the probability of A or B is 11/16, which when you plug into the calculator, it's 0.6875. And so the answer is, and then when you try to find a percentage from a decimal, just times it by 100. So the answer to this question is Jennifer has 68.75 chance of voting a sum that's either a 6 or an odd number. Right? And we'll do another example just for you guys to refresh on the new concept that we learned in this class. Do another example for you guys. Not bad, huh? I'm a teacher now. Okay. Example 2. Right? The question is, Xavier rolls 2 4-sided dice. Right? So Xavier rolls 2 4-sided dice, right? Determine the probability that he will roll a sum that's either even or greater than 5. Right? So determine the probability that he will roll a sum that is either even or greater than 5. Right? So step 1. Same thing as before. You have to look at this question and think about, is it mutually exclusive or not? And in this case, they're not mutually exclusive. Because it is possible for both events to occur simultaneously, since 6 and 8 are even numbers, and also greater than 5. Right? Because when you add the sums together, there's 6 and then 8, and also greater than 5. So step 2, you need to make the table of sums. Same as example 1, make a table of sums again. Right? And then, well, okay. Do it. There. 1, 2, 3, 4. 1, 2, 3. 4. So 1 plus 1 is 2, 3, 4, 5. 1 plus 2, 3. 1 plus 3, 4. 1 plus 4 is 5. 2 plus 2 is 4. 6, 5, 6, 7, 6, 7, and 8. So, if the question asks you, what's the probability he will roll a sum that is either even or greater than 5? The key words here are even and greater than 5. Basically, okay, you find even numbers first. Okay? Even numbers that are greater than 5. What are they? 6, 6, 6, and 8. They're all greater than 5. Okay? And odd numbers that are greater than 5 is 7 and 7. 7 and 7. Okay? So 66, 7 and 7 and 8. Okay? And then determine the step 3. Determine the individual probabilities in the table. And so basically, let C represent an even sum. So A represent an even sum, and B represent a sum that's greater than 5. Right? So we know, so use A, probability A as the even sum. Right? Even, there's even there's 8 over 16, and then let B represent a sum, rolling a sum that's greater than 5. Okay? So, rolling a sum that's greater than 5 is 1, 2, 3, 4, 5, 6. So probability of B is 6 over 16. Okay? And the probability, this is an overlap, and the probability of C and D is 4 over 16. This is overlap, right? So that is And then step number 4, calculate the probability. So basically, you go like, write the formula first as usual, right? Every time, remember that, write down what you're trying to find, write down the formula, and then you do everything else. So, probability of A or B equals the probability of A plus the probability of B minus probability of A and B, which is the overlap. Right? Make it more clear using the right. And then the probability of A or B. So what's the probability A? We know the probability A is 8 over 16. Right? So we use that, substitute in for probability A. So it's 8 over 16. Right? Plus the probability of B. What is that? We know probability of B is 6 over 16. So 6 over 16. Okay? And then minus the probability of A and B. So what's A and B? A and B is 4 over 16. Right? So, since we have another common denominator, all the common denominators are the same, then we use the top one. Add and subtract the top numbers. So, 8 plus 6 minus 4 is equals to 1. 8 plus 6, we all know, equals to 14. 14 minus 4 equals to 10. Right? So, the probability, in this case, of A or B is 10 over 16. Yeah, 10 over 16. Which is, if you plug in the calculator in decimal form, it is 0.625. Okay? And to find the percentage of that, you use 0.625 times 100. Okay? So, Xavier has 62.5% chance of winning, of rolling a sum that's even or greater than 5. And I think after these two questions, examples that we did, I think the class is probably clear about what's mutually exclusive and what's non-mutually exclusive, and how you solve for mutually exclusive and how you solve for non-mutually exclusive. Class is dismissed. So hard.